Good evening. Tonight, you'll discover what lies beyond numbers, beyond time, beyond space itself. You'll journey through the concept that has puzzled humanity since we first looked up at the stars. Infinity. 100 facts about the endless, the boundless, the eternal, that will guide you into the deepest, most peaceful sleep. But first, if you want more journeys like this, subscribe to the channel and leave a like right now, because in just a few minutes, you'll be too relaxed to move your fingers. Now then, make yourself comfortable. Let your body sink into your bed. Feel the weight of your limbs, heavy, relaxed. Close your eyes. Tonight, I invite you on a journey beyond boundaries, beyond endings, beyond the limits of what we can touch, or see, or fully comprehend. 100 remarkable facts about infinity, told slowly, gently, without haste. You don't need to understand them all. You don't need to grasp every concept. Just listen, and let these words carry you, like waves, into the ocean of sleep. Breathe evenly, deeply. Feel your chest rise and fall, and we begin. The symbol for infinity. Infinity is called a lemniscate. It looks like a figure 8 lying on its side, peaceful, balanced, flowing endlessly back into itself. This symbol was introduced in 1655 by an English mathematician named John Wallis. He chose it, perhaps, because it resembles a closed curve with no beginning and no end. When you trace it with your finger, you never stop. You never reach a conclusion. You simply continue, round and round, forever. But infinity is more than a symbol. It's a concept, an idea, something that exists in mathematics, in philosophy, in the human imagination. Infinity isn't a number you can count to. It's not the biggest number. It's something else entirely. Imagine counting. 1, 2, 3. You could count for your entire life, every second of every day, and you would never reach infinity, because no matter how far you count, you can always add one more, always. The word infinity comes from the Latin word infinitus. Infinitus means unboundedness, without limits, without borders, without an edge where things simply stop. The ancient Romans, lying in their villas at night, must have pondered this word, staring up at the ceiling, wondering about endlessness, just as you might be doing now, lying in your bed, letting your mind wander through concepts that have no walls. Humans have been fascinated by infinity for thousands of years. The ancient Greek philosopher Zeno, who lived around 450 BCE, created paradoxes about infinity, puzzles that made people think and wonder and question reality itself. One of his most famous paradoxes is about Achilles and a tortoise. In a race, if the tortoise has a head start, Achilles can never quite catch up, because every time Achilles reaches where the tortoise was, the tortoise has moved a little further ahead. The distance between them can be divided infinitely into smaller and smaller pieces. Of course, in reality, Achilles does catch the tortoise, but the paradox shows us how infinity can confuse our minds, how it can make the obvious seem impossible. Aristotle, another Greek philosopher, distinguished between two types of infinity: potential infinity and actual infinity. Potential infinity is like counting numbers. You can always count one more. The process never ends. But you never hold infinity in your hand. Actual infinity would be if all the numbers existed at once. Completed, whole, an infinite collection that somehow just is, for centuries. mathematicians debated whether actual infinity could exist, or whether it was just a beautiful, impossible dream. In mathematics, infinity behaves in strange and wonderful ways. If you add 1 to infinity, you still have infinity. If you add 1,000,000 to infinity, you still have infinity. Infinity plus infinity equals infinity. It's not that infinity is stubborn. It's that infinity transcends normal arithmetic. It exists in a realm where the usual rules bend. Interestingly, there are different sizes of infinity. This might seem impossible. How can something endless be bigger than something else that's also endless? But a German mathematician named Georg Cantor, in the late 1800s, proved that some infinities are indeed larger than others. He showed that the infinity of whole numbers is smaller than the infinity of real numbers, numbers with decimal points that go on forever. Two endless sets, yet one is somehow more vast. Cantor's discovery was so radical, so mind-bending, that many mathematicians of his time rejected it. Some thought he was wrong. Others thought he had lost his mind. The idea that infinity could have different sizes challenged everything people believed about mathematics, about logic, about reality. But Cantor persisted, and today, his work forms the foundation of set theory, a branch of mathematics that deals with the infinite. Let me tell you about the infinite hotel. Imagine a hotel with infinitely many rooms. Room 1, room 2, room 3, going on forever. And every room is occupied, now. A new guest arrives. Is there room? In a normal hotel, the answer would be no. But in an infinite hotel, the manager simply asks everyone to move. The guest in room 1 moves to room 2. The guest in room 2 moves to room 3, and so on. This creates a vacancy in room 1 for the new guest. Even though the hotel was full, infinity always has room for one more. Now imagine infinitely many new guests arrive. Still, the infinite hotel can accommodate them. The manager asks everyone to move to the room with double their current number. Room 1 goes to room 2. Room 2 goes to room 4. Room 3 goes to room 6. This frees up all the odd-numbered rooms, infinitely many of them, for the infinitely many new guests. Infinity, it seems, is generous beyond measure. But here's where it gets truly strange. Imagine infinitely many buses arrive, each carrying infinitely many passengers. Can the hotel fit them all? Remarkably, yes. With the right mathematical formula, every single passenger can be assigned a unique room number. Infinity contains infinity, contains infinity, nested endlessly, like Russian dolls that never run out. When you look up at the night sky, you're looking at something very close to infinity. The universe is vast, so vast that light from distant stars takes billions of years to reach your eyes. Some scientists believe the universe is infinite, that it goes on forever in all directions. No edge, no boundary, no wall where space simply ends. But we don't know for certain if the universe is infinite. What we do know is that the observable universe, the part we can see, has a limit, about 93 billion light years in diameter. Not because the universe ends there, but because light from beyond that distance hasn't had time to reach us yet. The universe is only 13.8 billion years old, and light, even though it's the fastest thing we know, still takes time to travel. If you could travel in a straight line through space forever, would you eventually return to where you started? Some models suggest the universe might curve back on itself, like the surface of a sphere, finite, but without boundaries. You could travel forever, and never reach an edge. But eventually, you might come back home. The universe contains approximately 100 billion galaxies. Each galaxy contains billions or trillions of stars. Each star might have planets. Each planet might have moons. The sheer number of celestial objects is so large, it approaches something that feels infinite. Even if the universe isn't truly endless, it's so vast that to our human minds, it might as well be. Between any 2 points in space, there are infinitely many points. If you want to travel from Earth to Mars, you must first travel half the distance, then half of what remains, then half again. Mathematically, you're crossing an infinite number of halfway points, yet somehow we arrive. This is another form of Zeno's paradox, the infinite divided, contained within the finite. Black holes present their own form of infinity. At the center of a black hole, according to our current understanding, lies a singularity, a point of infinite density. All the matter that falls into the black hole compressed into a space of zero volume. Infinite mass in no space at all. Of course, this suggests our theories are incomplete, that we don't yet understand what truly happens at the heart of a black hole. But the mathematics points to infinity. Will the universe last forever? Current evidence suggests yes. The universe appears to be expanding, and that expansion is accelerating. Galaxies are moving apart. In billions of years, they'll be so far apart that beings in one galaxy won't even be able to see other galaxies. The universe will grow cold, dark, empty, but it will continue eternally. This is sometimes called the heat death of the universe. Not a dramatic ending, not an explosion, just a slow, quiet dimming. Stars will burn out, black holes will evaporate. Eventually, nothing will remain but particles drifting in an endless void. And this state, according to current physics, will last forever. Infinite emptiness, infinite silence. But before then, the universe will exist for an unimaginably long time. Stars will continue to form for trillions of years. Galaxies will collide and merge. New solar systems will be born. Life, somewhere, might continue for eons beyond our own existence. The story of the universe is still being written, and it's a story that may never reach the end. Some theories suggest the universe might be cyclical, that after expanding forever, it could somehow contract, collapse back into a single point, and then explode again in a new Big Bang. An eternal recurrence, birth, death, rebirth, forever. If this is true, then our universe might be just one in an infinite series, universes appearing and disappearing like waves on an endless ocean. Time itself might extend infinitely into the past. The Big Bang happened 13.8 billion years ago. But what came before? Some models suggest time had no beginning, that there was always something before. An infinite regress, causes leading to causes leading to causes, with no first cause. Others suggest time itself began with the Big Bang, that asking what came before is like asking what's north of the North Pole. The question doesn't make sense. Either way, we're confronted with infinity, either infinite time, or the strange boundary where time begins. If you haven't fallen asleep yet, that's perfectly all right. Let these thoughts wash over you, like a gentle stream. You don't need to grasp them, just let them flow. Breathe deeply, feel your body relaxing, sinking deeper into comfort. And we continue. Numbers contain infinite patterns. Take pi, the ratio of a circle's circumference to its diameter. Pi is approximately 3.14159, but the decimal never ends, never repeats. It goes on forever. infinitely many digits, each one determined by the mathematics of circles. Within pi's infinite digits might lie every possible sequence of numbers, your birthday, your phone number, the complete text of Shakespeare's plays encoded in numbers. If pi is truly random and infinite, then every possible combination should appear somewhere, eventually. This is the nature of infinity. Everything that can happen does happen, somewhere in the endless sequence. Fractals are shapes that repeat infinitely. Zoom into a fractal, and you see the same pattern. Zoom in again, same pattern. Zoom in 1,000 times, still the same pattern. The detail never ends. No matter how close you look, there's always more complexity, more beauty, more repetition. Nature creates fractals, the branching of trees, the edges of clouds, the spirals of shells, coastlines, rivers, mountains. Everywhere you look, if you look closely enough, you find patterns repeating, self-similarity across different scales. Nature, it seems, has a fondness for infinity. The Mandelbrot set is one of the most famous fractals. It's a mathematical object created by a simple equation, but when you visualize it, you see infinite complexity. Zoom into the edge of the Mandelbrot set, and you find spirals within spirals, seahorse shapes, tendrils, each one containing more detail than the last. You could explore it forever and never see it all. Interestingly, fractals have what's called fractal dimension. Most shapes are one-dimensional, two-dimensional, or three-dimensional, but fractals exist between these whole numbers. A fractal might have a dimension of 1.5 or 2.7, something that doesn't quite fit into our normal categories. It's as if fractals exist, partially, in multiple dimensions at once, straddling boundaries, infinite and strange. Your mind, in a way, can comprehend infinity. Not completely, not fully, but you can think about it. Imagine it. Approach it from different angles. This is remarkable. Your brain, a physical object made of atoms and cells, can conceive of something that has no physical limit. Some philosophers argue that consciousness itself might be infinite, not in duration, but in depth, that there are always more layers to explore, more nuances to discover, more subtleties of experience. Each moment of awareness, when examined closely, contains multitudes, thoughts within thoughts, feelings within feelings. Dreams can feel infinite. Have you ever had a dream where time stretched strangely, where minutes felt like hours, where you lived entire lifetimes in a single night? The dreaming mind, freed from the constraints of waking reality, can create experiences that seem endless, that loop back on themselves, that branch into infinite possibilities. Perhaps right now, as you listen to these words, you're already dreaming, your consciousness drifting, blurring the boundary between waking and sleeping, between here and somewhere else. Let yourself float. There's no need to hold on, no need to stay alert. Just drift. Meditation practices often involve contemplating infinity, focusing on the breath, which has no beginning or end, just an eternal cycle of inhalation and exhalation, or visualizing space, vast and boundless, extending in all directions forever. These practices quiet the mind. By confronting it with something too large to grasp, the mind stops trying and finds peace. You are, in a sense, connected to infinity. The atoms in your body were forged in stars. Those stars existed billions of years ago, and those atoms will continue to exist long after you're gone. You're part of an endless chain, matter transforming, energy flowing, life appearing and disappearing across the infinite expanse of time. In quantum mechanics, particles exist in multiple states at once until observed. An electron can be in infinitely many positions simultaneously, a superposition of all possibilities. It's only when we look, when we measure, that the particle chooses a single state. Reality at the quantum level is infinite potential collapsing into singular actuality. Some interpretations of quantum mechanics suggest infinite parallel universes. Every time a quantum choice occurs, the universe splits. Both outcomes happen, but in different branches of reality. If this is true, then there are infinite versions of you, making different choices, living different lives. In one universe, you became an astronaut. In another, an artist. In another, you never existed at all. This is called the many worlds interpretation. It's not proven. It might not even be provable, but it's a mathematically consistent way of understanding quantum mechanics, and it suggests that everything that can happen does happen somewhere, in some universe. Infinite possibilities, all real. Imagine that for a moment. Every choice you've ever made, every path you didn't take, exists somewhere, fully realized. The life you're living is just one thread in an infinite tapestry. It's a comforting thought, and a humbling one. You're unique, and yet you're one of infinitely many. Even in a single universe, your potential is vast. The number of thoughts you could think, the experiences you could have, the connections you could make, approaches infinity. Every day is a chance to explore something new, to learn, to grow, to become someone slightly different than you were before. Your life, finite in duration, is infinite in possibility. Philosophers have long debated the nature of infinity. Is it real, or just a concept? Does it exist in the physical world, or only in mathematics and imagination? These questions have no easy answers, but pondering them can lead to profound insights about reality. The ancient philosopher Anaximander, who lived around 600 BCE, proposed that the universe originated from the apeiron. The apeiron is the infinite, the boundless, the unlimited. Everything we see, all finite things, emerge from this infinite source and eventually return to it, birth and death, as movements within the infinite. In many religious traditions, God is described as infinite, omnipresent, everywhere at once, omniscient, knowing everything, eternal, without beginning or end. Infinity, in these traditions, is a divine attribute, something that separates the creator from the creation. But some mystical traditions suggest that humans, too, contain infinity, that the soul is eternal, that consciousness is boundless, that we are, in some deep sense, one with the infinite whole. As above, so below, the microcosm reflecting the macrocosm, the finite containing the infinite. The philosopher Giordano Bruno, in the 16th century, proposed that the universe was infinite. He suggested there were infinitely many worlds, infinitely many suns, infinitely many planets, some of which might harbor life. For these ideas, he was burned at the stake. Infinity, it seemed, was a dangerous thing to believe in. But today, his vision doesn't seem far from our scientific understanding. The universe, if not infinite, is unimaginably vast and likely contains countless worlds. Let your mind rest for a moment. Feel the weight of your head on the pillow, the softness beneath you, the quiet around you. There's no rush. We have all the time we need, infinite patience for this journey. Breathe, and we continue. Between any two numbers, there are infinitely many numbers. Between 1 and 2, there's 1.5 and 1.25. and 1.125, and on and on. You can keep finding numbers in between, forever. The space between is endless. This means that even a small segment contains infinity. A line 1 inch long contains infinitely many points. Each point has no size, yet somehow, infinitely many of them make up that single inch. It's paradoxical, but mathematically true. The ancient Greek philosopher Democritus proposed that matter was made of atoms, uncuttable particles, the smallest possible pieces. He believed you couldn't divide forever, that eventually you'd reach something fundamental. And he was partly right. Atoms are very small, but they're not uncuttable. Atoms are made of protons, neutrons, and electrons, and those are made of even smaller particles called quarks. Can we divide forever, or is there a smallest possible thing? We don't yet know. In mathematics, we can divide forever. There's no smallest number. You can always go smaller. 0.1, 0.01, 0.001, approaching zero, but never quite reaching it. An infinite journey, inward. Time, too, might be infinitely divisible. Between 1 second and the next, there's half a second, and half of that, and half again. Is there a shortest possible moment? A quantum of time? Some theories suggest yes, others say no. If time is infinitely divisible, then every moment contains infinite sub-moments. Every now is infinite. Infinity creates paradoxes, statements that seem to contradict themselves, that break our normal logic, yet they arise naturally when we think about the endless. Here's a simple paradox. This set contains all sets that don't contain themselves. Does this set contain itself? If it does, then by definition, it shouldn't. If it doesn't, then by definition it should. It's a loop, a contradiction, created by trying to define something infinite. Bertrand Russell, a philosopher and mathematician, discovered this paradox in the early 1900s. It shook the foundations of mathematics, showed that our systems of logic, when applied to infinity, could produce contradictions. Mathematicians had to rebuild their foundations, create new rules to avoid these paradoxes. Another paradox. If you have infinite time, will you eventually do everything possible? It seems like the answer should be yes, but strangely, no. You could spend infinite time doing the same thing over and over. You'd never run out of time, but you'd never do anything else. Infinity allows for repetition, for patterns that never break, for eternity spent in a single moment. There's a thought experiment called the infinite monkey theorem. Imagine a monkey typing randomly on a typewriter forever. Given infinite time, the monkey will eventually type out the complete works of Shakespeare, every play, every sonnet, perfectly. Not because the monkey is smart, but because with infinite attempts, every possible combination of letters will appear, including the exact text of Hamlet. But here's the strange part. That same monkey will also type out complete nonsense, infinitely much of it. The works of Shakespeare will appear, but they'll be buried in an infinite sea of gibberish. Infinity is abundant, but abundance doesn't always mean meaning. Artists have tried to capture infinity in paintings of endless landscapes, in music that repeats and evolves, in sculptures that suggest continuation beyond what's visible. The Dutch artist M.C. Escher created drawings that loop infinitely, staircases that climb forever, water that flows uphill and downhill simultaneously, hands drawing themselves into existence. Escher's work makes infinity visual, tangible. You can see the endlessness trapped on a finite page. Music can feel infinite. A melody that resolves back to its beginning. A rhythm that cycles endlessly. Harmonies that layer upon each other, creating depth that seems bottomless. When you lose yourself in music, time stretches. Moments expand. You enter a state that feels timeless. The composer Johann Sebastian Bach wrote fugues that explore infinity, themes that repeat, that invert, that layer upon themselves in intricate patterns. Some of his pieces have no written ending. They simply continue. The performer decides when to stop, but the music itself could go on forever. Poetry can invoke infinity. To see a world in a grain of sand, an eternity in an hour. These words, by William Blake, suggest that the infinite hides within the finite, that everything contains everything else. A single grain of sand, if examined closely enough, reveals infinite complexity, infinite stories, infinite connections to the cosmos. Beauty itself might be infinite. There are infinitely many ways to arrange colors, infinitely many melodies to compose, infinitely many stories to tell. Art will never run out, because the human imagination is boundless. Let's pause here for a moment. You've been listening for a while now, drifting through concepts, floating through ideas. Take a deep breath, feel the calm, the stillness. You're doing beautifully, just listening, just being present. Gratitude can feel infinite. When you appreciate the small things, they multiply. A kind word, a warm cup of tea, sunlight through a window. Each moment of gratitude opens your awareness to more things to be grateful for. An endless cycle of appreciation. Love, too, can feel boundless. Parents often say they love their children infinitely, that there's no measure to it, no limit. And when a second child is born, that love doesn't divide, it multiplies. Somehow, there's infinite love for both. The heart, it seems, has no capacity limit. Kindness creates infinite ripples. One act of kindness inspires another, which inspires another, spreading outward, through communities, through generations. You might never see the full effect of your kindness, but it continues, echoing through time, touching lives you'll never know. In this way, you are infinite. Your actions, your words, your presence continue beyond your finite life. You affect others, who affect others, who affect others. A chain of influence, extending endlessly into the future. You might wonder, if we're all so connected, so infinite in our influence, are we really separate? Or are we, all of us, part of one infinite whole? Waves in a single ocean, threads in one infinite tapestry. It's a mystery, a beautiful mystery, that you can ponder as you drift deeper into rest. Let's return to numbers for a moment. Numbers are humanity's way of touching infinity, of trying to quantify the unquantifiable. The counting numbers 1, 2, 3, 4 go on forever. This infinity is called Aleph Null in mathematics. The smallest infinity. It's the infinity of things you can list, even if the list never ends. As long as each item comes one after another, it's countable infinity. But real numbers, numbers with decimals, form a larger infinity. Between any two whole numbers, there are infinitely many decimals, and this infinity is uncountable. You can't list all the real numbers, because between any two you name, there are always more. Georg Cantor, the mathematician who discovered this, proved it with a beautiful argument. Imagine you try to list all real numbers between 0 and 1. You write them down, 1 per line. Cantor showed you can always construct a new number, not on your list, by changing one digit from the first number, another digit from the second number, and so on. This new number differs from every number you listed, so your list wasn't complete. No matter how you try, you can't list them all. This means infinity isn't just one thing. There's a whole hierarchy of infinities, each larger than the last. Towers of endlessness, climbing ever higher. Mathematicians call this the continuum hypothesis. It's one of the deepest questions in mathematics, and we still don't fully understand it. Numbers can also be infinitely small. As we mentioned earlier, you can always divide by 2 and divide again, approaching 0 but never reaching it. Calculus, invented by Newton and Leibniz, is built on this idea. Infinitely small changes, infinitesimals, quantities so tiny, they're almost 0, but not quite. In calculus, we talk about limits. What happens as something approaches infinity, or as it approaches 0? These questions allow us to understand motion, change, growth, decay. For example, imagine a ball bouncing. Each bounce is half the height of the previous bounce. The ball bounces infinitely many times, each bounce smaller than the last. How long does this take? You might think, infinite time. But no, the ball comes to rest in a finite amount of time. The infinite bounces add up to a finite total. This is the magic of converging series. Not all infinite series converge though. If you add 1 plus 1 half plus 1 third plus 1 fourth forever, the sum grows without bound. It approaches infinity. But if you add 1 plus 1 quarter plus 1 ninth plus 1 16th, the reciprocals of squares, it converges. The sum approaches a finite number, about 1.64. Infinity, it seems, can sometimes contain itself, and sometimes it overflows. This is why calculus is so powerful. It lets us work with infinity, to tame it, to use it, to find exact answers to questions that involve infinite processes, the area under a curve, the volume of a complex shape, the trajectory of a planet. All of these involve infinity, but calculus gives us tools to handle it. Interestingly, some infinities cancel out. Infinity minus infinity doesn't always equal 0. It depends on how fast each infinity grows. Mathematicians spend years studying these subtleties, the dance between finite and infinite, the boundary where they meet. You might think infinity is abstract, distant, something only mathematicians care about. But infinity touches your life every day, in ways you might not notice. When you look in a mirror, that's held up to another mirror. You see infinite reflections. Each reflection contains a smaller reflection, which contains another. Fading into the distance, you're seeing infinity, right there, in your bathroom. When you stand between two mirrors, the reflections multiply. You see yourself, seeing yourself, seeing yourself, an infinite corridor of you, stretching away forever. It's eerie and beautiful, a glimpse of endlessness in a mundane place. Coastlines are infinite. When you measure the length of a coastline, the answer depends on the size of your ruler. With a 1 meter ruler, you get one length. With a 10 centimeter ruler, you follow more of the curves and bays, and the length increases. The smaller your ruler, the longer the coastline becomes, because you're measuring more detail. Mathematically, if you could measure at an infinitely small scale, the coastline would be infinitely long. This is called the coastline paradox. Snowflakes demonstrate infinity. No two snowflakes are alike, the saying goes, and it's essentially true. Each snowflake forms through a unique combination of temperature, humidity, and air currents. the number of possible combinations, is effectively infinite. Each snowflake, a tiny crystal of endless possibility. Your DNA contains vast information. 3 billion base pairs, arranged in a specific sequence, the instructions for building you. The number of possible DNA sequences is unimaginably large. Approaching infinity, you are one particular arrangement out of infinite possibilities, unique, irreplaceable. Stories are infinite. Every book tells a story. But there are infinitely many stories to tell. New combinations of characters, plots, themes. Humanity will never run out of stories, because the space of possible narratives is boundless. Even this script, these 100 facts, is one path through infinite possibilities. I could have chosen different facts, different words, different metaphors, but these are the ones that exist in this particular universe, in this particular moment, and you are hearing them, letting them guide you into sleep. Sleep itself can feel infinite when you truly rest, when you surrender to unconsciousness. Time disappears. You might sleep for 8 hours, but it feels like a moment, or like an eternity. Time loses its meaning. Dreams create infinite worlds. Each night, your mind generates entire universes with their own rules, their own logic, their own sense of reality. You visit places that don't exist, meet people you've never known, experience things impossible in waking life. And when you wake, these worlds dissolve. But while you're there, they're real, infinite and real. Some cultures believe sleep connects us to infinity, to the realm of spirits, to the collective unconscious, to dimensions beyond our ordinary awareness. Sleep as a journey, not just rest, but exploration of inner space, of boundless consciousness. Your breathing right now is a kind of infinity, in and out, repeating endlessly. As long as you live, feel it, the gentle rhythm, the rise and fall, like waves on an endless shore. Each breath bringing fresh oxygen, each exhalation releasing what you no longer need. An infinite exchange between you and the world. Your heartbeat, too, is an infinite rhythm, beating since before you were born, continuing now, will continue until your life's natural end. But even then, the energy continues. The atoms that made your heart will become something else, part of the eternal cycle. Nothing is ever truly lost, just transformed, forever. In Buddhism, there's a concept called beginningless time, the idea that existence has no start, that there was never a first moment, that the cycle of death and rebirth has always been. Whether this is literally true or metaphorically profound, it points to something important, that we might be part of something much larger than ourselves, something that extends infinitely in all directions. You don't need to understand infinity to be part of it. You don't need to grasp it, or define it, or explain it. You simply exist within it as an expression of it, like a wave is an expression of the ocean, temporary in form, but eternal in essence. We're approaching the end of our journey, 100 facts, though really, we've barely scratched the surface. Infinity, by definition, can never be fully explored, but that's all right. We don't need to know everything. We just need to have opened a door, to have glimpsed the endless. Mathematics will continue discovering new things about infinity. Philosophers will continue debating its nature. Scientists will continue finding it in the cosmos, in the quantum realm, in the structure of reality itself. But you can simply rest, knowing that infinity exists, that it's mysterious, beautiful, and utterly beyond complete comprehension. Perhaps the most important thing about infinity is how it makes us feel. Small, yes, but also connected, part of something vast. It gives perspective. Your worries, while real and valid, are also finite, temporary. They will pass. But you, in some sense, are infinite. Your impact continues. Your essence persists. In memory, in influence, in the atoms that will become other things. So as you drift off to sleep tonight, carry this thought with you. You are finite and infinite, bounded and boundless, a single point in an endless expanse. Both truths exist simultaneously. You are small enough to rest and vast enough to dream. And finally, this infinity isn't something to fear or to fully understand. It's something to accept, to marvel at, to let humble you and expand you. At the same time, the universe is infinite, or close enough to it that it doesn't matter. Time stretches endlessly. Numbers continue forever. Possibilities multiply without bound. And you are here, now, in this moment, part of it all. What a beautiful thing that is. So that's 100 facts about infinity, from mathematical symbols to cosmic expanses, from the infinitely large to the infinitely small, from paradoxes that break our minds to patterns that nature repeats endlessly. You've traveled with me through concepts that humans have pondered for thousands of years and will ponder for thousands more. But now, it's time to rest. Let go of these thoughts. Let them drift away. Like clouds, they've served their purpose. They've guided you here to this moment of perfect calm. Your body is heavy, relaxed, comfortable. Your mind is quiet, still, at peace. The infinite universe continues around you. Stars are born, galaxies spin, atoms vibrate, time flows. But you can simply be, simply rest, simply sleep. There's nothing more you need to do, nowhere else you need to go. You are exactly where you need to be, in this bed, in this moment, drifting gently into the infinite space of dreams. May you sleep deeply, may you rest completely, may your dreams be peaceful and boundless. Thank you for joining me on this journey. Good night, sleep well, and remember, as you float away into unconsciousness, into that mysterious realm where time means nothing, you are part of infinity, and infinity is part of you forever.